In the autumn of 2025, an object that had traveled between the stars for possibly billions of years came close enough to a planet in our solar system that space agencies scrambled every instrument they had to watch. It wasn't heading for Earth, but for a few tense weeks, it was heading close enough to Mars that a serious question started circulating in astronomy circles. Could this be the first recorded instance of an interstellar object actually striking a planet? The object was called 3I Atlas, and the story of what almost happened, and definitely did not happen, reveals as much about how science actually works as it does about the comet itself. This is the real account of 3I Atlas's pass by Mars, the genuine data, the genuine scare, the scientist who raised an explosives hypothesis, and what James Webb and a fleet of Mars orbiters actually found when they looked. 3I Atlas was discovered on July 1st, 2025, by a NASA-funded telescope in Chile built specifically to scan the skies for exactly this kind of object. The Atlas Survey, short for Asteroid Terrestrial Impact Last Alert System. Within days, astronomers confirmed what made it extraordinary. This wasn't a comet, native to our solar system. It was only the third interstellar object ever detected in human history, following Oumuamua in 2017 and Borisov in 2019. Its path was immediately unusual. Unlike a normal comet bound in orbit around our sun, 3I Atlas was moving on a hyperbolic trajectory, meaning it was never captured by the sun's gravity at all. It was simply passing through on a one-way trip that would eventually take it back out into interstellar space, never to return. But before it left, its path would carry it deep into the inner solar system, and, astronomers quickly realized, disturbingly close to Mars. Chapter 3. A trajectory that crossed the red planet's path. As astronomers refined their tracking of 3I Atlas through the summer of 2025, the numbers kept tightening. The comet's orbit would carry it inside the orbit of Mars itself, a genuinely close pass in astronomical terms for an object arriving from outside our solar system entirely. By early October 2025, the picture became precise. On October 3rd, 2025, 3I Atlas made its closest approach to Mars, passing at a distance of roughly 29 million kilometers. A wide gap by everyday standards, but close. Enough that it created something rare in astronomy. An opportunity to observe an interstellar object, not just from Earth, but from spacecraft already stationed at another planet. NASA's Mars Reconnaissance Orbiter turned its instruments toward the comet. So did China's Tianwen-1 orbiter and the UAE's HOPE orbiter. The European Space Agency did something even more inventive. It repurposed its ExoMars Trace Gas Orbiter, a spacecraft, built to study the Martian atmosphere, and pointed it at 3I Atlas instead. Because that spacecraft was already orbiting Mars, it was roughly 10 times closer to the comet than any telescope on Earth, giving scientists an entirely new viewing angle and dramatically sharpening their prediction of the comet's path. For a moment, planetary scientists had something they'd never had before, a genuine test case for planetary defense using a real interstellar object and a fleet of spacecraft already in position to watch it. Chapter 4. The hypothesis that made headlines. It was around this point that the story took a turn that spread far beyond scientific journals, and it's important to understand exactly what was actually claimed, because the way it got reported afterward went well beyond the original science. Harvard astrophysicist Avi Loeb, known for his willingness to publicly entertain the possibility of artificial origins for unusual interstellar objects, published a paper examining the comet's trajectory. Working with a student, Loeb calculated a specific hypothetical scenario. If 3I Atlas received an additional push of roughly 10 kilometers per second of momentum during September 2025, from a source the natural outgassing of ice on its surface couldn't fully explain, the comet's path could, in theory, be altered enough to result in an actual collision with Mars. That's a real, published calculation. It's also, critically, a conditional if scenario, not an observation, not a prediction of what was actually going to happen, but a model of what it would take for a collision to occur, alongside Loeb's broader argument that the comet's trajectory, passing unusually close to Venus, Mars, and Jupiter in sequence, was statistically striking enough to warrant considering non-natural explanations. Loeb and his co-authors went further in a later paper, explicitly raising the possibility that the object could be technological, and in their words, possibly hostile. They pointed to gas jets and course behavior they argued weren't fully explained by ordinary cometary outgassing. This is where the story split in two. In the actual scientific community, Loeb's papers were read, debated, and, by the overwhelming majority of astronomers studying the object, set aside as an interesting but unsupported hypothesis, resting on a chain of ifs rather than direct evidence. In large parts of the internet, the conditional collision scenario was stripped of its conditions entirely and reported as a near-certain imminent impact. While the alien technology hypothesis was spreading online, the actual instruments watching 3I Atlas were returning a very different, far more grounded story. James Webb's near-infrared spectrograph, pointed at the comet on August 6, 2025, detected a coma, the hazy envelope of gas surrounding the nucleus, dominated by carbon dioxide, with water, carbon monoxide, water ice, and dust mixed in. The ratio of carbon dioxide to water was unusually high. Compared to solar system comets, a genuine anomaly worth studying, but a chemical one, not evidence of engineering. The Mars Reconnaissance Orbiter's imagery and the higher resolution HiRISE camera aboard it captured detailed views of the comet during its closest approach, alongside data from Tianwen-1's imaging system. None of it revealed anything inconsistent with a natural comet undergoing normal solar heating. A nucleus outgassing as it warmed, a tail forming as ice sublimated into space, brightness increasing as it neared the sun. Exactly the behavior astronomers expect from a large, ancient, ice-rich object approaching a star for what may be the only time in its multi-billion-year existence. By early December 2025, follow-up observations combining Hubble and Webb data had refined the comet's solid nucleus to roughly 2.6 kilometers across, large for an interstellar object, tens of times more massive A than the previous record holder, but consistent with an extremely old, extremely large natural comet, not a spacecraft. Here's the plain, verifiable outcome. No additional 10 kilometer per second momentum boost occurred in September 2025. No collision took place in October, or at any point since. 3I Atlas passed its closest point to Mars on October 3, 2025, at a distance of roughly 29 million kilometers. Nowhere near an impact, continued past the red planet exactly as its natural, unaltered trajectory predicted, and swung around the sun at perihelion in late October, reaching speeds of roughly 153,000 miles per hour under the sun's gravity. NASA's own published information on the object is direct about this. 3I Atlas never posed a danger to Mars, Earth, or any other planet in the solar system. At its closest approach to Earth in December 2025, it remained nearly twice the distance between the Earth and the Sun away, nowhere close enough to be any kind of threat. The collision course headlines that circulated afterward, some explicitly claiming James Webb had confirmed an impending impact, did not reflect anything NASA, ESA, or the JWST science team actually published. They appear to have originated from a combination of speculative blogs amplifying Loeb's conditional hypothesis without the conditions attached, and in some cases, entirely fabricated claims about Webb data that don't exist in any peer-reviewed publication or space agency release. Chapter 7. Why the close pass still mattered. None of this means the Mars flyby wasn't scientifically significant. It was just not for the reason the panic headlines suggested. Having multiple spacecraft already stationed at Mars during an interstellar object's passage was an unprecedented opportunity. ESA's use of its trace gas orbiter to observe 3I Atlas from 10 times closer than Earth-based, telescopes allowed scientists to refine the comet's predicted trajectory by a factor of 10, a genuine leap in precision that mattered enormously for planning further observations as the comet continued its journey. That kind of triangulated multi-spacecraft tracking is also, quite literally, a real-world test of planetary defense capability, proving that if a genuinely dangerous object ever did appear on a collision path with a planet, humanity's existing network of spacecraft could rapidly coordinate to track and predict its behavior with remarkable precision. ESA itself described the campaign as a valuable proof of concept for exactly that scenario, even while being clear that 3I Atlas itself posed no danger at all. Chapter 8. The difference between a hypothesis and a headline. The 3I Atlas story is worth pausing on for a reason bigger than one comet, because it's a clear, documented example of how a legitimate scientific hypothesis, published with careful conditional language, can morph into something unrecognizable by the time it reaches a headline. Loeb's actual published work laid out a specific, narrow conditional scenario. A collision was possible only if the comet received an unexplained momentum boost that had not been observed. That's a legitimate thing for a scientist to model and publish. It's exactly the kind of what would it take calculation that helps define what to look for next. What it is not is a prediction, a confirmation or evidence that a collision was actually going to happen. By the time it reached blogs and video titles, the conditional had vanished, James Webb confirms, had been attached to a claim Webb's own data never supported, and a hypothetical became, for a large online audience, a settled fact. That gap between what scientists actually published and what circulated as breaking news is where most of the internet's most viral space stories tend to live. Having passed Mars without incident and swung around the Sun, 3I Atlas is now on its way back out of the solar system entirely, retreating along the same hyperbolic path that brought it in, accelerating away from a star system it will never revisit. Astronomers are continuing to track it as it departs, refining its size, composition, and age estimates with each new observation, work that has already revealed genuinely remarkable findings without needing any invented collision to make the story compelling. A nucleus possibly older than the solar system itself, a chemical signature unlike any comet studied before, and confirmation that objects arriving from other star systems can be significantly larger than the first two examples suggested. Chapter 10. What actually happened here? So, to answer the question directly, James Webb did not confirm a collision course with Mars, because there was no collision course to confirm. What actually happened was a genuine, close, and scientifically valuable flyby. The first time humanity had spacecraft already positioned at another planet to observe an interstellar object passing nearby, paired with a legitimate but conditional scientific hypothesis that got amplified online far beyond what the actual data supported. 3I Atlas is not a threat, was never a threat, and is now leaving. What it leaves behind is a genuinely fascinating scientific record, and a useful reminder of how quickly a careful, if this, then that calculation from a serious researcher can be flattened into a false certainty by the time it reaches a video title. The real story was never a catastrophe. It was something quieter and, in its own way, just as extraordinary. For a few weeks in 2025, humanity's spacecraft at Mars got a front row seat to a visitor from another star, passed safely and kept going.